The blacksmith was the king of all tradesmen. Without the blacksmith's ability to make and to repair tools, no other craftsman would be able to keep going for long. They'd all come in to have tools worked on or special tools made. So the blacksmith was vital for any community. This is the blacksmith's anvil. In this particular shop, this is an engineer's anvil because it has this little piece here called a table, and it has two hardy holes for putting tools in. The important bit is the beak here, or the bick, which is used for forming anything round, and particularly horseshoes if the blacksmith was a farrier. The face of the anvil is where the majority of the blacksmith's work is carried out, and it's his most important tool for making anything out of hot metal. For cutting off metal, a hardy would go in the hardy hole, and this is a hardy which allows the blacksmith to cut metal while it's hot. Also, forming tools such as this for making a tapered component could fit in, and this anvil allows you to do two operations almost simultaneously when the metal's hot. The Pritchell hole is used for punching holes through hot metal, and particularly with the tool a farrier uses to make the nail holes in his horseshoes, which is called the Pritchell, so it punches straight through. When it comes to dating how old an anvil actually is, there are a number of clues that are useful. The face is made out of steel, and it's not often a very thick piece of steel. And sometimes you can see where it's been welded in a fire onto the rest of the anvil, which is made of iron, not steel. Early anvils generally wouldn't have a table like this. They go straight onto the beak or the horn of the anvil. That was a point of weakness on early anvils, and often they cracked or broke off when they were abused and had lots of heavy use. On early anvils, sometimes you see numbers made in the side, either stamped in it or cast onto it, and they tell you the weight of the metal in the anvil, usually 3 numbers. But this anvil doesn't have any. It's a later design. It's probably made of solid steel rather than welded together out of wrought iron with a steel face. And this is probably early 20th century. Anvils go right back to the earliest days of blacksmithing, and the blacksmith would collect iron together and make his own originally. But they came into their own when they needed to make horseshoes and armour for the knights to go on the horses. And that's when the classic design of anvil developed. The blacksmith's next most important tool after the anvil is his hammer. And hammers come in a huge variety of sizes and shapes, each for a specific purpose. The biggest version of the ball peen is this one, which is about as much as anybody can hold in one hand. So after that you have to go for what's called a sledgehammer. Anything above a 4-pound hammer needs 2 hands to work it, so you have a longer handle which takes the 2 hands. Here's a traditional blacksmith's hammer with a straight pane at the one end. This is solid steel. You can tell that because the date stamped in it with the government arrow, little army surplus one, is 1943. This is a 10-pound sledgehammer made locally. It says Thomas Smith, Oldbury. Never been used. But this would be the heavy flogging hammer for big forgings, used by an apprentice or a blacksmith assisting the actual working smith. The army were very good at stamping everything they made with the broad arrow and the date 1943, this particular hammer. After the First War and after the Second War, army surplus tools would be bought by blacksmiths because they were really good quality and they were very cheap. And most collections would have some army material in with dates on, so look out for that. The blacksmith's next essential tool is a pair of tongs for holding the hot metal. Without those, he'd burn himself trying to do any work at all. They get your hands far enough away from the source of heat to be safe to work. And they came in a variety of shapes and sizes, but of several different types for holding different sorts of metal. This one here holds round metal, about half an inch diameter, or 12 millimeters if you've gone metric. This one's very specialised. This again would hold a square section of iron or steel in the fire. It's practically impossible to date a pair of tongs because the design just never changed. Once they developed a tool that worked, they kept making it. So the design didn't change, the only difference is the way they were made. If you're very lucky when you're trying to date or accession an object like this, it's stamped. This one's stamped G, which doesn't tell us a great deal, but sometimes you'd find a manufacturer's name, but more often than not the blacksmith would have made the tongs himself because it was the first thing he learnt to make was his own tools. If you're exceptionally lucky, they're army surplus again, and you might find the manufacturing date stamped in them and the broad arrow, again from after the First War or the Second War. Blacksmiths would always look out for cheap tools that were good quality. The bellows, full-size bellows the blacksmith uses are mounted somewhere near the hearth so that the blast will go straight into the fire. This set's mounted up high out of the way so it gives room underneath. The lever here provides the action to pump up the bottom half of the bellows into the top half of the bellows, which provides the main blast. So a few hard pumps and the bellows are supplying large quantities of air to blow up the fire. And this is a job for the apprentice while the blacksmith is hard at work. The design goes right back into the 1600s and possibly before. Again, it's leather from cows to provide the main fabric for the bellows. Old wrought nails originally. These had to be specially made when these were refurbished. But there's nothing about the design that gives away its age.